Okay. Good morning, everyone. And welcome to the hints for the formative quiz number 3. So the formative quiz number 3 has 6 items, 6 problems, and is due on November 4. First problem is what a short ride. A block of mass m, shown in figure, equals 10 kilograms that is initially moving to the right with a velocity u at 10 meters per second slides along a frictionless track as shown in the figure. Okay. It moves down a distance d equals 5 meters deep below the valley before rising to a final height h of 2.35 meters. Okay. So it slides down with a distance d and then rise up to a final h. So this is the h, this is the d. Okay. And then after, it moves through a rough horizontal surface with a friction coefficient mu, which is 3.345. Okay. So this is frictionless. The valley is frictionless. The initial surface is frictionless, but the final surface at the top has a friction. Okay. First question, what is the speed of the block at the bottom of the valley? Okay, what is the speed of the block at this bottom? Okay, ano yung speed here? Okay, so here we can use conservation of energy for an initial and final state. So for almost all of these problems, we can now use work kinetic energy theorem and conservation theorems, conservation of energy and linear momentum, to be able to solve the problems. So what you need in conservation theorems is just the initial state and the final state, or the initial configuration and the final configuration of your system. Okay, so dapat kayo mag-define kung ano yung initial state and final state as well as yung coordinate axis. Okay, you can always set where your y equals 0 or x equals 0 for a very, very convenient way to reduce yung mga number of terms. Okay, so here, what we can do is use conservation of energy at the state when the block is initially moving to the right, this one. So this is the initial state. Let me change my color. Okay, so this is the initial state. So dito yung E1, saka K1 and U1. So dito nyo i-define yung E1, K1, and U1. And then yung final state would be yung nasa bottom of the valley, which is now this. Ngayon, dito nyo naman i-define yung E2, K2, and U2. Again, K's are kinetic, so total kinetic energy, ano yung mga nagbibigay ng kinetic sa energy sa object. And U ay yung total potential energy. So, lahat na nagbibigay ng potential energy, may it be elastic or gravitational, kailangan nyo i-take into account. So, dito, you need to know if, you need to state whether gravitational potential energy lang ba yan, GPE, or elastic potential energy. Okay. And again, conservation of energy is always the change in energy must be 0. Meaning, change in energy, right? Which is E2 minus E1, yun yun. E final minus E initial, lagi siyang 0. So that's why from this equation, pag transpose natin si E1 sa kabila, we have E2 equals E1. Okay. And now, E2 is yung total kinetic energy, K2 plus U2. Right? And then E1 is yung K1 plus U1. Okay, and then from this, you have to find the values for kinetics and the potential energies for the initial and final state. Okay, so don't forget to always set your y equals 0 or x equals 0 in a convenient way to reduce your terms and to simplify your calculations. Okay. So that's for letter A. For B, question is, what is the speed of the block just before it traverses the rough surface? So ngayon, just before it traverses on the rough surface. So again, we define our initial state and final state. So yung just before it traverses, ito yung rough surface, right? And this is the rough surface. So, ang nasa natin yung block is somewhere in this. Okay. So, pwede nating sabihin na yung point of center of mass niya nandito or yung point of contact niya is nandito. Okay. So now, we can now define initial and final state. So this is, we can define this as the initial state. Okay. So ito yung may E1. And then yung final state is nandun na siya sa taas. This one. That will be your E2. Okay. So and again, we use conservation of energy. Okay. Okay. So dito magbabago yung height. Iba yung height nito, iba yung height nito, iba yung height dito. So iba yung Y. So yung Y yung magbabago dyan. And of course, yung V din. Kasi iba yung speed dito, initial, which is U. Iba yung speed dito, yan yung kinuha mo kanina sa letter A. Iba rin yung speed ngayon dito, yan yung kinukuha ngayon sa B. Okay. Now for letter C, how far along the rough surface will the block travel before it stops? Okay. So for this, para mabawasan yung effect nitong nung nag-slide yung block kanina. So pwede na nating kunin yung initial state and final state to be in this surface lang. Right? So yung initial state, yung nandito siya just above the surface. Just above the, just before the rough surface. Right? And then yung final state is kapag nandito na siya somewhere. Okay. So ang tinatanong, how far along? So ano yung distance na pwede niyang abutin? From here to here. Okay. So ito yung initial state, ito yung final state, right? So we can now use work kinetic energy theorem for this. So again, work kinetic energy, work done by your force, right? By the force. So dito, frictional force lang siya. Okay. Should be equal to the force done, which is a friction, times that product with the displacement S. Okay. So yun yung hinahanap, yung displacement S. Okay. So again, this is just equal sa magnitude of the force. Magnitude of the force times magnitude of the displacement. Cosine theta. Where theta here is defined as yung angle between these two vectors. But we see that the force, the frictional force is going there. Let me use another color. The frictional force is going there. The displacement is going here. Right? So ano yung angle between sa kanila? Ito na lang. Ano yung angle between? That is 180 degrees. So cosine 180, that's just 1. Or -1. So that's just -1. So you will see here, meron kang negative magnitude ng frictional force, kung ano man yung force na yan, magnitude ng displacement, and then times -1. Okay? Then from there, you can find the displacement. Yung work naman, equal yan sa kinetic energy. Right? So total kinetic energy, yun yung work kinetic energy theorem. So kung ano man yung kinetic energy, dapat equal yan dito. Okay. Okay. Second item or second problem. Okay, this is titled three-way collisions. Three blocks are placed on a frictionless surface. And so this is a surface and wala siyang friction. So frictionless yan. Two blocks of the same mass, ml, mmr, which are both 2 kilograms, are moving toward a middle third block with the mass m 1 kilogram. So this is the small mass. So the left block ml moves with the speed u naught of 3 meters per second, and the right block moves with the speed of v naught which is 2 meters per second. So si ml nagmo-move to the right, si mr nagmo-move to the left. Wait. Okay, malito ha. ml, the left block moves to the right and the right block moves to the left. The middle block is initially at rest. All succeeding sa collisions will be classified as head-on and elastic. So assume natin na lahat ng mga collisions na itatanong for this problem will be head-on and elastic. Okay. So first, ML initially collides with M. So si left muna nag-collide with M. So ito lang yung tinitingnan pa lang. Okay. What are their velocities after collision? So again, for any collision, we use the conditions for or conservation theorems appropriate for the problem. So all collisions dapat conserve ang momentum. All collisions conserve lagi ang momentum. Okay? But if the collision is head-on and elastic, right, then dapat conserve din si kinetic energy. Okay? So yan yung conditions for an elastic collision. If may collision, automatic conserve si momentum. If elastic, then automatic conserve din si kinetic energy. Okay? So yun lang yung gagamitin natin. So dito, ito yung tinitingnan nating window. And meron kang ulit initial and final, right? So initial state is this one. Yung before sila mag-collide. Okay. Gawin na lang natin. Right? So initial state is yung before sila mag-collide. Final state is yung directly after collision. So ito meron siyang u naught. Ito meron siyang v naught. Kung ano man yung v naught niya. Sabihin na lang natin w. Kasi v naught pala. W naught. Right? And then sa final meron tong uf. And then meron din to wf. Speed f. Ay hindi, wag na nga lang w. Ano ba maganda? Ano maisip? UM na lang, UM. If U naught, tas ito ay UM 0 o UM initial. And then this has UF and this has U small m F. Okay. So ito yung initial state before collision. Ito yung after collision. And then you now solve the conservation of kinetic energy and momentum. Okay. Kung ano yung applicable. Okay. Now, next question. After collision with ML, M now collides with MR. What are the velocities of M and MR after the second collision? So ngayon, nag-collide na si ML sa si M, right? Ang tinatanong naman, si M magko-collide with MR. Okay. So, si M naman magko-collide with MR given na si M nag-collide na with ML. Okay? Given to. Okay? Given na nag-collide sila, after nung collision nila, magko-collide si M kay MR. So, initial state natin is yung final state Tm after nung collision. Right? So, yung initial state, lagyan natin dito. Initial state is si M and si MR. Si MR, meron siyang V0. Pero si M, meron siyang, anong ginamit natin kanina? UMF kanina. Okay. Ito ngayon yung initial state. Ito yung before. Okay. After, ano yung ngayon yung mangyayari? After ng collision. So, after ng collision, si MR magkakaroon siya ng VF. Si small mass, magkakaroon siya ngayon ng UMF. Sabihin na natin prime. Or second, yan yung ibang initial momentum. So, this is U prime. So, U prime M. Okay. Okay, so gets ba yun? Yung initial state ngayon ni M is yung final state niya sa letter A. Kasi nag-collide muna sila and then magko-collide kay MR. Tapos, sa letter C, itutuloy lang ulit natin yung collision. Okay? So ngayon, after nung collision niya ulit sa MR, magko-collide ulit siya kay ML. Okay? So what are the velocities of M and ML after the third collision? Okay, so again, elastic collision, conservation of kinetic energy and momentum. Pero again, iba na naman yung initial velocity for both cases. So yung initial velocity ni M, nandun sa letter B, yung final nun. Okay, so yung final velocity ni M sa B, yun yung magiging initial velocity niya ngayon sa C. Tapos yung initial velocity ni ML is yung final velocity niya sa A. This is from A, this is from B. And then solve yung conservation theory. Okay? Okay. Number 3, to the finite. Yeah. A block with mass M of 1.2 kilogram, this is it, at rest is pressed against a spring with a spring constant K of 255 newtons per meter, compressing it by 18 centimeters. 18 centimeters na compression. The mass is then let go and goes up a ramp at an inclined angle of theta equals 35 degrees above the horizontal. The first question, what is the speed of the block immediately before it goes up in the incline? Okay. So for this, again, wala tayong collision. So we just stick with conservation of energy. Okay. Again, with conservation of energy, important ko ni initial state and the final state. So initial state natin, pwede nating set as this. Yan, yung naka-press siya, yung naka-compress. Okay. Yung naka-compress, yun yung initial state. Yan yung may E1, K1, and U1. Okay. So, dahil natin di-define. Ngayon, ano yung final state? Ang tanong, what is the speed of the block immediately before it goes up the incline? Okay. So, ang tinatanong, immediately before it goes up the incline, yun siya yung nandito. Okay. Yan yung final state. Okay. So, final state will be this one. Yung nasa baba lang siya ng incline. Okay. So, dyan mo ngayon de-define yung E2, K2, and then U2. Okay, ano yung kinetic energy niya, ano yung potential energy niya, at so that malalaman mo yung total energy at the final state. Again, we can set our y equals 0 or x equals 0 for in a convenient way to reduce the number of terms and simplify our calculations. So we can always set where our potential will be 0. Okay. So yun yun. Yung reference natin. Okay. And then for letter B, how far along the incline's length does the block travel until it comes to a rest? Okay. Use conservation of energy at the state when the block is pressed against the spring and at the state when the block comes at the rest at the incline. So dito, conservation of energy ulit, but now, same pa rin yung initial state natin. Right? We can still set this as our initial state E1, K1, and U1. Pero yung final state ay yung nasa taas na yung block. Okay. So in this state, dito natin i-define yung E2, K2, and U2. Kung ano man yan. And then finally, yung makukuha mo dito, of course, yung makukuha mo dito is usually yung height. Right? So again, drawing natin dito yung incline. Theta yan, theta. So nandito yung object, right? So yung makukuha mo dyan, na final answer is yung maximum height. Pero ang tinatanong, how far along the incline's length? Okay. So actually, ang tinatanong ay this one, this distance. Okay. So ano ngayon? This distance, L. Sabihin natin L yan. Okay. So you need to use trig relations to relate the maximum height, itong maximum height na maaabot that the block will reach with the distance as it travels along the incline or the hypotenuse L. Okay. Kaya given yung theta. Okay. So ito yung hinahanap yung L. Sabihin natin. Ito yung hinahanap. Okay, yun yung final dapat na answer dyan. Okay. Number 4, soft drop. A block with mass M equals 1.25 kilograms. Ito yun. Is held at a distance H, is H, which is 1.5 meters above a spring. This is the spring with a spring constant K of 240 newtons per meter as shown in this figure. Okay. The mass is then let go and eventually, so bumaba, let go yung mass, and eventually compresses the spring by an amount of delta X. First question, what is the speed of the block immediately before it touches the spring? So again, it's we should clearly define initial state and final state, or initial configuration, final configuration. So we can take this as our initial configuration, right? Yung hindi pa nare-release yung mass. Okay? Kasi alam natin yung potential energy nito, alam natin potential energy nito, and alam natin yung kinetic energy ng system. So this is where you define E1, U1, and K1. Okay. Now, ang final state natin will be just before, again, just before the mass touches the spring. Okay. Ibig sabihin, ito yung platform, ito yung spring, just before. So, kaka-hit niya palang halos. Okay. So, Remember this keyword just before, immediately before it touches the spring. Okay? So ano ibig sabihin nun sa spring? So dapat hindi pa na-compress si spring. Okay? So dapat hindi pa na-compress si spring. Okay? So yan yung final state natin. E2, define U2, and then K2 there. Okay? Again, don't forget to set your y equals 0 and x equals 0 in a convenient way to reduce the number of terms and simplify your calculations. Okay. Next question, what is the magnitude of delta x? Ngayon, ano ngayon yung maximum, ano ngayon yung compression ng spring delta x? Okay. So dito, ang initial state natin is still the same. We can just take this as our initial state, but then our final state would be yung mass na compress niya na yung spring. Okay. So kanina, hindi pa niya na-compress yung spring kasi before it touches the spring pa lang siya. Ngayon, na-touch niya na para may compression. So ano ngayon yung compression na to? Ano yung magnitude ng compression? Okay. So dyan mo ngayon set yung bago mo energy. Okay. And then conservation of energy. Note, when the spring is fully compressed, okay, when the spring is fully compressed, the velocity of the block will be 0 in that moment. In the moment na yung spring mo fully compressed, yung velocity ng mass or block na to should be 0. Same siya ng nangyayari kapag yung sa projectile, yung mass mo nasa maximum height. Diba? Sa projectile, kung yung mass mo nasa maximum height, velocity ay 0. Velocity along y is 0. So, ganun din dito. When the spring is fully compressed by the block, then the block's velocity is 0 at that instant or at that moment. Okay. Okay. Number 5. Collide to 1. 3 pucks with masses m sub A, 25 grams. Remember, it's grams. M sub B is 50 grams and M sub C 75 grams. Approach the origin as they move on a frictionless table. Okay. So they are all moving towards the same origin. Okay. Puck A moves with speed VA 3.5 meters per second, while puck B moves with a speed V sub B of about 1.25 meters per second and is oriented at an angle beta of 72 degrees below the horizontal as shown in this figure. So ito si beta. Okay? Ito si beta. All the pucks arrive at the origin at the same time and stick together, causing it to move at 0.12 meters per second to the positive x direction. Okay. So yung collision natin, since they stick together, ano to? This is perfectly inelastic collision. or in general, this is an inelastic collision. Okay? So inelastic siya. Inelastic. Inelastic. Yeah, I think it's also perfect. Perfectly inelastic collision. And then, kung inelastic siya, sa end, dapat magko-combine yung masses nila and they move as one. So, yun yung nangyayari sa perfectly inelastic collision. They move as one after sticking together. And yung movement nila has a speed of 0.12 meters per second to the positive x direction. Positive x direction. Okay. So, what must be the x and y component of C's initial momentum for this described collision to happen? Okay. Okay. So here, we can let angle of gamma be the angle of proxy with respect to the horizontal. So, ito yun. So, drawing na lang natin dito. Yan. So, ito yung V sub C. Dito si mass C. Moving at the VC. Okay. So, let this be gamma. Okay. And then we use conservation of momentums for 2D or two directions, X and Y directions. From there, we can solve the X and Y component of momentum of path C. Okay. So again, conservation nanto ng momentum, hindi na energy. Kasi may collision na tayo. Pag collision, always conserve ang momentum. But since now, inelastic siya, so hindi conserve ang kinetic energy. Hindi always conserve ang kinetic energy. Okay. So ang sure lang natin, conserve ang momentum. So now we draw our initial state and our final state. Okay. So yan yung gamma. This one. So ito yung initial state. Right? Yung they're just approaching the origin. Ang final state will be that they stuck together or they stick together. Okay. They stick together and they move at a speed of 0.12 meters per second. Okay. 0.12 meters per second. V sub F. So this is now your final state and this is your initial state. Okay. So here you will define the PF, the final momentum. But here, sa initial state, dito nyo i-define yung PI, initial momentum of each box or of the system. Okay. So ngayon, ang tinatanong, ano yung X and Y components ng initial momentum ni C? So kailangan meron kang PIC, or P1C, P1B, and then P1A. Okay. So dyan nyo siya i-define. Dito naman, meron ka lang isang final momentum. Okay. For letter B, what must be the magnitude and direction of box C's initial velocity for the described collision to happen? So magnitude and direction of initial velocity of box C. So remember from letter A, from question A, we get the momentum of box C initially. Diba? So from A, we get yung P initial ng C. And we know that this is M times V, right? This is a vector actually. So vector yung P kasi alam natin yung X and Y component niya, right? And then equal sa M times vector V or yung V sub 1, C. Okay? Ngayon, ang tanong, ano yung magnitude and direction nitong vector na to? Okay, so makuha mo yung vector form niya, yung component form, kasi na yung P mo naka-component form. So meron kang something I hat dyan, something J hat. Okay. So ganun din dito. Pagdating dito, makuha mo rin is something I hat plus something J hat. Since magnitude and direction yung tinatanong, so you need to convert it into magnitude-bearing form. Okay, so paano ulit kinukuha yung magnitude? Paano ulit yung kinukuha yung magnitude? Okay, so meron kang square root, no? V1cx squared plus V1cy squared. Okay, and then yung angle or yung direction will be theta c equals tangent pala. Tangent theta c is VCY over VCX. Okay. Okay, so magnitude bearing form yung kailangan dito. Kailangan nyo i-convert. Okay. Letter C, what is the change in the system's total kinetic energy? Okay. So ano ngayon yung change? Alam natin na hindi siya conserve kasi perfectly inelastic collision. Right? Nag-stick together. So alam natin hindi zero yung delta K. Delta K is not zero. Not zero. So ano ngayon tong delta K na to? So ano ngayon siya? Ano yung value niya? Okay. So we can get it using, of course, K2 minus K1. Okay. So where K1, ito yon yung nasa initial state, yung K2, makukuha natin dun sa final state kung saan nag-stuck together na sila. So meron na tong K2. And then we can get this delta K, the change in kinetic energy. So yun you will get the kinetic energy, the total kinetic energy before and after collision. So before collision, may kinetic energy si A, may kinetic energy si B, may kinetic energy si C. Ganon din sa after. Pero dapat, since nag-stick together, ano ngayon yung itsura nung final form? Nung final kinetic energy. Okay? So sa letter D, did the system lose energy after the collision? Okay. So we can answer this using yung nakuha natin sa letter C. Okay. Sa letter C, nakuha natin ngayon si delta K. Right? If this is positive, then energy is gained. Nag-increase yung energy. If the change in the kinetic energy is positive, then nag-increase yung energy. Okay. If the change is negative, if the delta K is negative, then yung energy natin is lost. Okay? So ito yon, lost energy. If delta K is 0, so i-add lang natin to, then energy is the same. So there's no change in energy, meaning na-conserve yung energy. Okay. So ang tanong, alin dito yung sagot? Okay. Okay, number 6, Blackozone. A mass of M 25 kilogram block slides down at an angle theta of 36 degrees incline as shown. Okay. So ito yung mass M sliding back down with an angle theta, leaving the end with the speed of UM. So after nito, pag nahulog na siya sa incline, meron na siyang speed of UM of 1.20 meters per second. At the same time, a mass of capital M, big M, of 75 kilogram cart, whose top end is located distance h of 3 meters below the end of this chute, of this incline, right? This cart moves to the left with a speed of u sub big M of 3 meters per second and catches the block as it falls. Okay, so magka-catch sila. Once the cart catches the block, both move with the same speed. Okay. So para din siyang collision sa after. Para kang may collision and nag-stick together sila. Okay. So here we ignore friction for all cases. So we ignore friction sa incline and we ignore the friction here. And we also ignore the friction between them. Okay. So we ignore friction in all cases. Okay. First question, what is the speed of the block just as it hits the cart? Just as it hits the cart. Okay. So for this, we can use conservation of energy, right? And then define our initial and final state. So again, this is our initial state, right? How about our final state? So ang final state natin is, this is your cart, and then si mass small m nasa taas. Pero hindi pa siya masyadong bumaba. Like just before it hits the cart. So before pa yung mangyari yung pag-hit. So malapit na mag-hit yung mass m. Okay? So dito yung final state. And here we define your E2, K2, and then U2. Okay. Ito naman, define natin E1. Total yan. So total kinetic energy ng both masses. Same with this. So lahat ay total. K1, U1. Again, we don't forget to set your origin or reference point, y equals 0 and x equals 0 in a very convenient way to reduce the number of terms. So kapag maganda yung pagkakaset nyo ng y equals 0, then some of the terms you will just vanish in your conservation theorem. Okay. Pag sinolve nyo na yung conservation of energy, maraming mawawala. If tama yung pagkaka-define nyo ng axis or ng coordinate axis. Okay. Next, what is the velocity of the block cart system after the cart catches the block? Okay. So here, since collision siya, after ma-catch ni cart yung block, nagkaroon ka na ng collision. Okay. So with that, kung collision na yan, we can now use conservation of momentum. Okay. So before yung sa letter A, hindi natin magamit yung collision, conservation of momentum kasi hindi pa nag-hit si mass kay cart. Right? Before pa lang before pag-hit. Dito, nag-hit na siya. Na-catch niya na ng cart yung block. So, nag-collide na sila. So, with that, pwede na natin gamitin yung conservation of momentum. Okay. So, now, ang conservation of momentum natin is, so, ito yung initial state. Again, then yung initial state, meron ka dyang P1 for both cases, P1M and P1M. And then, yung final state mo is na-catch niya na. Okay. Na-catch niya na yung small mass M. So, dito, meron ka na ngayong P2 nung system. Okay. Again, this is a perfectly inelastic collision. Perfectly. Nag-stick together sila di ba? Naging one combined mass sila. Okay. That is for B. And then for letter C, finally, what is the change in energy of the cart and block immediately before and immediately after the collision? Okay. So immediately before and immediately after the collision. Okay. So we find the kinetic energy of the system for both. So this is the total of the block and cart immediately before and immediately after, and get the difference between the two. Okay. So again, ano yung immediately before? Yung immediately before, yan yung meron kang mass M, meron kang small mass, sabihin natin ganyan muna. Pero hindi pa sila nagko-collide. Right? Hindi pa sila nagko-collide. So ano ngayon yung velocity nito? Ano yung velocity nito? Okay. So yung velocity nito, ano yung velocity ni mass M is yung nakuha mo from letter A. Remember. Yun yung before it hits the cart. Yan. Tapos ito, may velocity din to na yung sub M. Tapos yung final state ngayon is after na ng collision. So nag-collide na sila. Okay. So ngayon, meron na silang final velocity na nakuha mo from letter B. Right? So yung final velocity nito, makuha mo from letter B. And so you can define your K2 here, and then yung K1 there, and then we just get the difference, the change in energy. Actually, dapat yan change in kinetic energy. Okay? It should be change in kinetic energy. So, K2 minus K1. Okay? So, change in kinetic energy lang yan. Okay. So, with that, yan na yata yung last item, I think. Yep. Okay. So, good luck. And again, the deadline for the formative quiz number 3 is on November 4. So, good luck and have a meaningful and restful reading break. So, sana mahabol natin yung mga backlogs and makapagpahinga pa rin tayo at some point. Okay? Okay. Bye-bye.